Sorry guys, my screen decided to stop recording. So I'm going to rewrite my answer as y inverse equals 5x plus 1. Now I notice, because I'm going to be asked my domain and range, I notice that my equation is y equals mx plus b form, which means that it's actually a straight line on my graph that's going up. So I know my domain and range are going to be from negative infinity to positive infinity for both. Remember, domain is always read from left to right. Range is always from top to bottom. All right, for number 7. We are expanding. Actually, for 7 and 8, this is not supposed to be solved. This should also be, actually not expand. This one's going to be condense. I'm not solving because there is no equal sign for me to solve with. All right, for 7, logarithm. It's division. Division means that in order to expand it, I'm going to have to make them subtractions. So I'm going to rewrite it as log 50 minus log x. All right, for number 8, first I move the numbers that are in the front. So this is going to be a cube. He's been moved. And addition is occurring between them, so multiplication is going to occur to condense. So I'm going to have ln of x times 3x cubed. Well, I can actually kind of reduce this a little bit further. I know that this is actually going to be an ln. That 3 cubed becomes a 27, x becomes x cubed. And of course, I can condense it a little bit further, so I get ln of 27x to the power of 4. Now, 13. Remember, it says solve. I know it's solved because I have an equal sign as well. So equal sign, solve. First thing that I have to do to solve number 9, I have to move the 13. Move addition and subtraction first. Then you're going to move your multiplication and division. So plus 13 plus 13. I get a 4ex equals 29. Now I move my division, divide by 4. 29 and 4 do not reduce any further, so they're going to say 29 over 4. So I get e to the power of x equals 29 over 4. To get rid of an e, I have to do the natural log. So in my calculator, I will put x equals ln 29 over 4. And whenever I round these, I know I'm going to round it to 3 decimal places. It's the best rule of thumb that you can have. So plug it into your calculator and you will get about 1.981. Looking at 10, I have a log minus a log equals a log. Well, I need it to be in equal to log format. So I'm going to have to condense the first part of my equation before I can go about solving. So to condense, I know that there is subtraction occurring between them. So I know that this is going to be division to condense. So I get x plus 10 divided by x minus 2 is now equal to just log x. Once I do that, logs can be dropped. And then I can go about solving. So I have x plus 10 divided by x minus 2 is now equal to x. Remember, to move division, I have to multiply by x minus 2 on both sides. Remember to use your parentheses, so that's gone. I'm left with x plus 10 equals, I distribute to get x squared minus 2x. When I have an x squared, I now know I need to move everything to the other side so that I can solve it. So I'm going to do a minus x and a minus 10, minus x, minus 10. So that I have to solve x squared minus 3x minus 10. Well, to do this, I'm going to actually have to factor what times what gives me negative 10, but adds to be a negative 3. Well, I get an x minus 5, x plus 2. Solve, and I get an x equals 5 and x equals a negative 2. Well, remember, I'm not going to automatically discount that negative 2, but I am going to plug him in so that I'm going to try him out to see if I get a positive number when I do the math. So I get a negative 2 plus 10. Well, this one adds to be an 8, so he would work, but negative 2 minus 2 becomes a negative 4. He doesn't work, so because of that, it can't be negative 2. It has to be 5. Remember, you always have to plug it in and check first. And again, I would also plug in that 5. 5 plus 10 is 15, and 5 minus 2 is a positive 3. He works out. Oh, sorry. Also, plugging him into that log x also automatically would say he's not going to be a solution. All right, so now we're looking at transformations. Remember, we need to know our parent functions for these. So question 11, it says, what family of functions does g belong to? Well, he's shaped like a V, so I know that he comes from the absolute value family. Now it says, well, what is the basic function of f of the family? Meaning, what is the parent function? Well, it's f of x equals the absolute value of x. If I were to draw him, he would look like this on my graph. Okay, so from there, knowing my parent function, I'm going to figure out what the transformations are. So, well, I need to know a couple of things first. I'm going to figure out what the stretch is first, because I know from the top I'm going down 2 over 1. So down 2 over 1. So I know I have a stretch. All right, so I'm going to, first I know that he's flipped. So he is flipped over the x-axis. He has a vertical stretch of 2. It's not negative 2. That negative made the flip. The stretch is just the 2, the number. Let's see. Then I know that he's shifted left 1. So he's shifted left 1. And he went up 2. And then he went up 2 units. So now I'm going to write the equation. All right, so this is actually g of x. And he equals, remember, flipped over the x-axis is a negative. He has a stretch of 2. It's an absolute value of x. Remember, if he went left 1, well, that means he's a plus 1 on the inside. And then he just went up 2 units. All right, using the graphs at the right, we're going to find the following. All right, so we're doing f plus g of negative 3, meaning this is f of negative 3 plus g of negative 3. All right, so I'm going to go to negative 3 and I'm going to draw a line. Because where it hits this line is going to be my solutions that I'm going to add together. So f of negative 3, well, that's the blue one. So I go to that line and he has an answer of 1. And I'm adding them, so that's plus g of negative 3. I have an answer at negative 2. So plus negative 2. So my solution is negative 1. I can erase my line. Now I'm going to do f of 0 minus g of 0. So again, I'm going to draw my line at 0, which is just the x-axis. And I'm going to find my points, which is their solutions. Well, f of 0 is the blue, so that's at negative 2, minus g of 0 is at 1, so that is minus 1, which gives me a solution of negative 3. Well, now I'm doing f times g of 0. So same answers, but I'm multiplying them together. So remember, f of 0 was negative 2. G of 0 was a positive 1. So I now have a solution of negative 2. Now again, I'm going to take those same answers because it says f divided by g of 0. So that's going to be my negative 2 for f of 0 divided by 1. So another solution of negative 2. Now I'm going to erase my last line. And now I'm looking at f divided by g of negative 1. So again, I draw my line at negative 1. Let's see, f has an answer of negative 3. G has an answer of, well, 0. Ooh, if I remember correctly, a number over 0 is a no, so it is actually undefined, which is my answer. Now, this next one, f of g of 0. So first I'm going to find g of 0, and then I'm going to use that answer to find f of 0. So find g of 0 first. So again, I'm going to draw my 0. G of 0 is 1. So I get 1. But then I'm going to do f of that 1 that I got for the answer. So f of 1, go to the 1. And where does it fall? Well, at positive 1. So the answer is still 1 for this guy. Now I'm going to do f of negative 3. So I'm finding the solution at negative 3. Well, that was at 1. And then I'm going to find g of the answer, which was 1. So I go to 1 and I see where g of 1 occurs. Well, that's at 2. So I'm finding the first term, and then I'm using that solution to find the next term. Now, it actually wants us to take and find the vertex form and the slope-intercept form. Well, remember, vertex form is a of x minus h squared plus k. And of course, this one is y equals mx plus b. Sorry, this is y equals. All right, so to find that, well, I need to find my point, right? He occurs at negative 1, negative 3. So it's y equals x. I went left 1, which is a plus 1 squared. And then I went down 3. The downs and ups, well, that's negative 3. Now, to see if I have a vertical stretch, I'm actually going to plug in first 0 and see if I can get that negative 2 for the solution. So 0 plus 1 is 1 squared. 1 minus 3 is negative 2. Well, guess what? That works out. I'm going to do it again, and I'm going to plug in a 1, and I'm going to see if I can get the answer of 1. So 1 plus 1 squared is 2 squared is 4. 4 minus 3 is 1. So this actually has no vertical stretch that I have to change. All right, now slope-intercept form. Remember, I'm first looking for my y-intercept, which is at 1. So y equals plus 1. Then I need to find, is it up 1 over 1, up 1 over 1? Well, that's up 1 over 1, so that it's just 1x, or you can write it as y equals x plus 1. All right. Given our image here, given our graph, it wants to know what the domain is. Remember, you're looking for some key features like closed circles, open circles, and end arrows or not. So domain, remember, is always reading it from left to right. So to the far left, I want to know what is my farthest point to the left. Well, that occurs at negative 5. Farthest point to the right, well, that's an arrow. So that goes on to infinity. So negative 5 on to infinity. So now I'm looking again. My range is from bottom to the top. So from the bottom, again, I have an arrow at the bottom of my graph, and to the top, well, draw my line. It goes all the way up to 4. So it will go from negative infinity up to 4. I'm going to erase what I did. Zeros. Well, okay, I need to find my points. I have one at -1, 1, and 3. So I have x equals -1, 1, and 3. I'm going to erase those. Relative minimums, those are the curves that are at the bottom. So they're bottom curves. So I have one here. I have one here. And I don't have another one because I have an arrow at the bottom. So relative minimum, well, I need that actual point. This actual point is at -4, 2. This actual point is at 0, -1. So those are my minimums. So I have one at -4, 2, and at 0, -1. Now I'm looking for my maximums. So again, I'm going to go to the ones that go up, and I'm going to plot those. So this one is, of course, at -3, 3. This one is at 2, 1. Notice I did not use this very top one up here at the top. Well, I didn't use him because he is my absolute maximum. So I can't use him yet. So -3, 3, and 2, 1. Now, I said minimum and maximum. Well, that means my absolute minimum and my absolute maximum. Well, because my arrow, my bottom of my graph goes all the way down to infinity, I have none. I have no absolute minimum. Absolute max point on my graph, well, that's this guy at the closed circle, which is at -5, 4. So I'm going to put -5, 4. All right, I'm going to erase those. Now I'm doing my increasing intervals. Increasing, well, that's from here. Where is it increasing? Remember, I'm only looking for x values, so I'm going to draw my points. It increases. I'm going to draw all of my points. Maximums, minimums, the whole 9s. All right. Because I'm only worried about the x values. So I know that it's decreasing for this one. It increases for this one. Decreases for this one. Increases and decreases. Okay. Now I'm specifically looking just for the increasing intervals. So remember, it's increasing on this one is from -4 to -3. Union. It increases from this point occurs at 0 all the way up to 2. So 0 to 2. I'm done. Remember, for these increasing and decreasing intervals, only use parentheses. We're no longer worried about brackets. Okay, decreasing intervals. Oh, wait, I say that, but you actually do need to for this first one because it is a closed circle. We do worry about this one. So from -5 to -4, it's decreasing. Union. For this next one, it goes from -3 all the way to 0. And then this next one, it goes from 2 all the way down to infinity. So, sorry, union. Whoops. 2 to infinity. Because I'm reading it from left to right. Is it a function? Yes, I just did a whole bunch of vertical lines and it didn't hit 2 points, so that works out. Now I'm going to look for specific solutions. When our graph is 0, our solution is, well, at 0 it is -1. at -2? Well, at -2, I actually have to follow it up. And I get answer of 2. When our graph is 5, well, again, I go to that 5, I draw a line. Let's see, it occurs at -4. Now, let me erase all this. For this last part, it wants to know for what part of the graph is f of x greater than or equal to 0. Well, it wants to know what parts of the graph is the answer greater than 0. Well, that's all of everything above the x-axis. So it's all my x values above the x-axis. So from -5 to -1, well, that all occurs above the x-axis. So from -5 to -1. And then union from that second part occurs between between 1 and 4. So, or not 4, 1 and 3. So from 1 to 3 is greater than 0. Now it says f of x equal to 5. So from 5 and at 5, do I have any solutions? Well, I have no solutions. Oh, that is it. If you have further questions or you need further assistance studying for your final exam for 171, please do not hesitate to email me, message me on Remind, whatever you need to do. We can meet one-on-one. I can also have a group session if there is enough of you. I wish you the absolute best of luck. It has been a pleasure teaching you. I wish you the best of luck in your further academic career.